Okay, so we are going to go over problem 872 from your homework. So first of all, the thing that's going to help you out with this problem is if you make a diagram of what's going on. All right, so we have Sandeep. Here's Sandeep. He is standing on the floor, and he notices that there's a mirror lying on the ground. Here's my mirror. He is 8 feet away from the mirror, so 8 feet. And the mirror is 10 feet away from the wall, 10 feet. There is a clock on the wall, and he wonders how high up the wall is that clock. His eyes are 64 inches off the ground. Okay, so the first thing I notice about this is I've got feet and I've got inches, and I want everything to have the same units. So let's change these so that they have the same units. So how many inches would 8 feet be?
96.
Okay, so I'm going to make this 96 inches. And how many inches would 10 feet be?
120.
120 inches. Okay. Now, when he looks into the mirror, his reflection or his line of sight will reflect back up here. I know that if he's standing, he's perpendicular to the floor, and I know that the wall is also perpendicular to the floor. So there was a lesson where we actually skipped it, unfortunately, but there was a lesson where you would look into a mirror and look up into somebody else's eyes. So this question may have made more sense to you if we'd done that lesson, but we didn't do it. But this is a good question anyway, so let's work through it. The thing you need to know is when you reflect into a mirror and out again, that angle of reflection is equal. So what do I know about these two triangles here?
They're similar.
They're similar. Okay, so I've got similar triangles. So that means that I can set up a ratio and solve that ratio for x, and that will help me find out how high up the wall the clock is. Okay, so I want to find x, so that means I'm going to put x on the top of my fraction. And the other value from that triangle is 120, so I'm going to put that here. Okay, which side in the smaller triangle corresponds with x?
64.
Okay, so I'm going to put 64 up in the top, and the side that corresponds with 120 would be 96. So now I am going to solve this equation. To solve it, since x is being divided by 120, I'm going to multiply by 120. And that will give me x by itself. Okay, I don't have a calculator on me. Can one of you guys help me out? I would like you to do 64 times 120 and then divide that by 96. Because remember, when we multiply a fraction by a whole number, we just multiply the numerator. So
80.
Did you divide by 96?
Yes.
It's 80?
Yeah.
Okay. So that means it is 80 inches off the ground. How high would that be in feet? How would I change that to feet? What would I do?
6 and 2 inches.
6 feet.
Or 6 and 8 inches.
Okay, so it would be 6, what is it, 6.6 repeating, is that what it is? Okay. So 6.6 repeating, which means it's 6 feet, 8 inches off the ground. Okay, how do you feel about that one? Okay? Does that make sense? Okay, how many of you guys want to go over this one, problem 873? This is a good idea to go over because you're going to be doing a lot of area of regular polygons today, so let's kind of refresh our memory of how to go over this. So we have Mr. Singer has a dining table in the shape of a regular hexagon. While he loves this design, he has trouble finding tablecloths to cover it. He's decided to make his own tablecloth. In order for it to drape over each edge, he'll add a rectangular piece along each side of the regular hexagon as shown in the diagram at right. So we need to find the area of cloth that he needs to use. Okay, so I know that this whole length is 6. The way we find regular polygons, the way we find their area is by splitting it up into congruent triangles, right? That's off a little bit, but you get the idea. So if that whole length was 6, what would this partial length be?
3.
Okay, so this is going to be 3. So the first step in finding the area of your regular polygon is to find the central angle. So my central angle is going to be 360 degrees divided by the number of triangles that I have. How many triangles do I have? 6. So that means it's going to be 60 degrees here. All right, but if I'm trying to find the area of this one triangle, I need to find my height. I don't know what that is, but I know that this whole thing is 60. That means half of it will be 30. Then I can use some right triangle trig, or I could also use my triangle shortcuts because it's a 30, 60, 90. The triangle shortcuts will only work for hexagons. If you have a shape other than a hexagon, you have to do right triangle trig, so sine, cosine, or tangent. All right, so I know since this is going to be an equilateral triangle, I know that the entire base of my triangle here is 3. Then I can find the short leg would be 1.5 because it's going to be half of the length. And then my long leg, which happens to be the height of my triangle, is going to be the short leg times the square root of 3. Okay, so somebody with a calculator, tell me what 1.5 times the square root of 3 is. 1.5 times the square root of 3. What does that equal?
2.59808.
Okay, so we'll call it 2.59. So then that means the height of my triangle is 2.59. The base of my triangle is 3. So the area of my triangle is going to be the base times the height divided by 2. So 2.59 times 3, what's 3885? Okay, so the area of my triangle is equal to, say that again? 3.885. How many triangles do I have?
6.
I have 6 of them. So that means the area of my hexagon is going to be 6 times 3.885. Which is 23.31. Is that all that he needs for his tablecloth?
No.
Nope, because then I have to add on those 6 rectangles. So the rectangles, they have a length of 3 because they're on the end of the hexagon there, and a width of 1. So that means they have an area of 3 times 1, 3, and there's 6 of them. So then I would have to add on 18 to get my total. Okay, questions about that one?
Wait, why did you do the square root of 3 when calculating the...
Why did I do the square root of 3 when calculating the height? Because this is a 30, 60, 90 triangle. The height is the long leg. It's across from 60. And the long leg is always the short leg times the square root of 3. And my short leg was half the hypotenuse, so it was 1.5. So that's the short leg times the square root of 3 to give me the long leg. For a 30, 60, 90, yes. If it's not a 30, 60, 90, then you have to do sine, cosine, or tangent. What other questions do you have?
Could you have done that if you didn't want to do...
Could you have done sine, cosine, or tangent? Absolutely, yep. Yep, you could definitely have done that as well. Any other questions about this one? No? Okay, let's talk about the dodecagon one. 884, the dodecagon cookie. We're gonna do the same thing as we just did, except instead of a regular hexagon, now we have a regular dodecagon. Okay, so let's start by finding my central angle. I'm going to do 360 divided by what number if it's a dodecagon? 12. Okay, so that means my central angle will be 30 degrees. All right. And if my central angle is 30 degrees, and I'm going to split it up here so that I can find, oops, I'm going to split it up here so that I can find my height. Each part of this height is, or each part of this triangle is going to be half of 30 or 15 degrees. Okay, I need to find my height. I need to find that length right there.
Are you recording this?
I can't do the 30, 60, 90 because it's not a 30, 60, 90. So that means I have to do some right triangle trig. So which trig ratio should I do? tangent, because I have the opposite leg. What would this length be? 3. And I have the adjacent leg, h. So I can do the tangent of 15 equals 3 divided by h. So tangent of 15 degrees equals the opposite divided by the hypotenuse. Or h is equal to 3 divided by the tangent of 15 degrees. Okay. So if I do 3 divided by the tangent of 15, I get that my height is 11.2. Okay, so now I'm going to find the area of my triangle. The base of my triangle is 6. It's from right here. The height is 11.2. And if I'm doing a triangle, I have to do base times height divided by 2. So I'm going to multiply 11.2 times 6, and then I'm going to divide it by 2. And I get that the area of one triangle is 33.59. What's the area of my cookie then? What do I have to multiply that by? 12. So I'm going to do 12 times 33.59 to get the total area, because there were 12 congruent triangles. And I get the total area is 403.06. My units were centimeters, so it would be centimeters squared.
Is it 406?
So if you rounded earlier in the process, your number might be off a little bit from where mine is, because I didn't round until the end. Okay? All right. Any questions about finding the areas of right triangles? No? Okay, cool. We're going to be doing some work with this stuff today, the area of triangles today. But for right now, let's put our homework away.
Okay.